Hello, my name is Tom Haynes and I work on the user experience team for Rational Team Concert. In this demo you will learn how to gather source code data and query, edit, and use the information to analyze dependencies. This demo assumes that for your project area, your stream has been selected for source code data scanning. As software grows in size and complexity, it is harder to easily recall or determine relationships between and among components, files, data sets, etc. With this functionality, you can use existing parsers or add your own to run periodically and automatically against sets of source code artifacts to gather and update data about the code. That data can then be utilized in dependency builds, searched to find objects that match given criteria, viewed and edited, and mined to discover impact relationships, files that depend on a given file, and other files upon which a given file depends. We'll start by creating a query to search for specific types of source code data. Select New Query from the context menu over the Source Code Data node. Note that from this menu you can also reset the data and select additional streams for scheduled scanning. This editor looks and behaves like the work item query editor. Select the big plus sign icon to define a criterion. For this example, we pick the language attribute. Let's select the COBOL choice. Now we run the query. A set of files are found that match the search criteria. Let's open one in its source editor. Next we'll view metadata using the source code data editor. First we switch to the resource perspective. Note this explanatory text. We will demonstrate adding a user-defined data item. Note the new example instance has been added. Read the helpful section text. This tab shows helpful scanner statistics. Next we will search for dependencies, both on and of the select file, to assess impact of potential changes. We'll start by accepting the defaults and look for files that this file depends on. Note that one file was found. This time we look for files that depend on this file, using the more time-intensive Physical Dependency Advanced Scope option. Both a language and a build definition must be specified. Note that one file was found. Finally, we show how to assign a language definition to a file. The selected language definition is applied to all files that were selected after applying any filter specified in the Files group box. As an alternative to explicitly assigning language definitions, you can associate a language definition to a file automatically based on file extension. To do so, first we open a language definition in its editor. Notice the File Extensions field. If you specify an extension of CBL there, for example, all files ending in CPL that aren't explicitly associated with a language definition will be associated with this one. A language definition has two purposes. One, to identify the translators or steps to be run on each file during a build, and two, to specify the scanners to be run on each file when performing a source code data scan. I hope this demonstration has been helpful. Be sure to view the other demos available for Rational Team Concert and related products.